So it goes from nothingness to all of a sudden, essentially in like 3 steps, we have life. We have a prokaryote. Is there anything that happens between like nothingness and is it atmosphere and hydrosphere?
The atmospheric pressures reach basically levels.
So something has to happen with present levels to reach our atmosphere, right? Something gaseous has to happen. So we had to have that at the very beginning, right? Because our timeline started moving. I moved without anything being said. So we definitely had to have that. Remember when I described to you guys early Earth? What did I tell you early Earth was like? So early Earth was hot, gooey, tarry ooze, primordial soup, primordial stew, hostile, rainy, violent weather patterns. And I compared early Earth to what modern day land formation? Volcanoes. So early Earth was hot and violent. The gases that made up the atmosphere of early Earth, not free oxygen. There was no free oxygen. O2, the stuff we breathe, the stuff that autotrophs release, none of that, because it's super reactive. And even if it weren't super reactive, the Earth is being bathed in UV radiation. Why?
There's no atmosphere to prevent the sun.
Yeah. No atmosphere and hydrosphere, no ozone layer. That nice, like, comfortable bubble in which we exist didn't exist. So it was being bathed with harmful UV radiation from the sun. Now, harmful, you have to define harmful to what? Well, if there's nothing on Earth, it's not harmful to anything. So that's a relative term. The atmosphere was much like current volcanoes. So we have CH4. CH4 is a gas we call methane. You guys familiar with methane at all? Where have you heard of methane? So, why do you say cigarettes? Okay. Cows expel methane, so do you, truthfully. Your little methane factories. Some of you seem amused by it, others are like. So methane is a byproduct of our digestion. Actually, it's not us, it's not our fault, it's the bacteria that reside in our stomachs. Same for the cows, it's the bacteria that reside in their stomachs. Methane is a highly explosive gas, very flammable. And it's what, when you go into chemistry, you're going to use to fuel your laptop burners, your tabletop burners that you light on fire. That's what we use in chemistry as a source of fuel. Exceptionally flammable. NH3, ammonia. So atmosphere or early atmosphere of ammonia, methane. You guys know what ammonia is? For those of you who don't, let's see if I have mine here. Where's my little Bo Peep? Well, truthfully, it's probably because we're staying safe. Ammonia, you guys may recognize it as a bottle that looks roughly like this, but it doesn't say bleach. You'll never see it stored next to bleach because if the two combine, it makes mustard gas. So if you go home this evening and you're looking for ammonia because you want to smell it to know what to compare it to, and you find it in your laundry room or your pantry stored next to the bleach, do your family a favor and move it. Ammonia is that stuff that smells, well, like ammonia. It's got little Bo Peep on the container. It's one of the main brands. It is what we call a classic irritant. It'll say that right on the label when you find it tonight. It'll say big letters, irritant. Don't, if you are so inclined to smell it, don't just stick it right up to your nose and inhale. Waft it. Classic science smelling. Why? Because it will irritate your nasal passages badly enough that it will cause nosebleeds. It's an irritant. So far, early Earth is surrounded by a highly flammable gas and a nasal irritant. Doesn't it sound pleasant? Sign me up. I'm going there. No? No? Drive. Some water vapor. Vapor only. And hydrogen gas. I don't remember whether it's high school social studies or middle school. You guys know what the Hindenburg is? The dirigible? What happened to it? Blew up. Why did it blow up? The gases inside of it caused it to catch on fire. It was full of hydrogen. Hydrogen's very buoyant, has, less density than the air or the oxygen that's around us, so it's going to float, right? Turns out, when you concentrate a great deal of hydrogen in one spot, boom. Big boom. When you concentrate hydrogen into a spot and then allow it to run into power lines, well, oops. So that's what happened there. This is early Earth. Does that sound like a pleasant place for living things? Not especially. So early scientists, actually not even early scientists, scientists in the 1950s were asking themselves, where did life come from? If we know this is all true, if we know that it looks like a volcano with trace amounts of hydrogen sulfide gas, which would be H2S, trace amounts of hydrogen sulfide gas, all of these very flammable, very violent things, somewhere in that walk down the hallway, something had to happen to make life happen. So they developed different explanations for where life came from. And we're going to immediately rule out a couple of them. One, a divine being made the first organisms and placed them on Earth. Why did scientists rule that out? Why did they say we cannot examine this hypothesis?
They can't prove it or test it.
Yeah, it's not testable. So they're like, okay, can't talk about that hypothesis. Another potential explanation for where life on Earth came from. Another planet. Really simple. Came from another planet, deposited here. Now I'm not suggesting TARDIS style came from another planet. I mean a meteor came from another planet, crashed into Earth, and that's how life got here. Testable? What do you think? Not testable. So we can talk about it. That left scientists to try and develop their own hypothesis for where life could have come from. So, the possible explanation that some scientists outlined for us is called the heterotroph hypothesis. The heterotroph hypothesis. Occasionally also called the Oparin-Haldane hypothesis, because J.B.S. Haldane, and I don't remember Oparin's first name, Quite frankly, JBS isn't even a first name, those are his initials. Oparin and Haldane are the scientists who developed this potential explanation for where life came from. Their hypothesis relies on not biological evolution, but chemical evolution. You can't have biological evolution until you have things that are alive, right? Biology means life. So they had to start pre that, developed a theory of chemical evolution we call the heterotroph hypothesis. And it has 3 basic parts. So 3 parts of their hypothesis. There had to be a supply of inorganic molecules on Earth. And that supply of inorganic molecules had to somehow form what you guys refer to as monomers. I didn't leave enough space. We're going to cross out number 2 because I didn't leave enough space. And those inorganic molecules had to, in some way, form the monomers of our biomolecules. Now, this is a big stretch because of the word or the prefix bio. They're suggesting there had to be an inorganic source for organic molecules. In assertion number 1, there has to be an inorganic source for organic molecules. This for you right now should be a stretch. You should be looking at that and being like, that doesn't fit with everything else I've known about my biomolecules so far. Number 2 of their hypothesis, those monomers had to somehow find a way to create polymers. So they had to start, after they were created, they had to start attaching to each other to make big biomolecules. So to make nucleic acids and lipids and carbohydrates without something living. And the third part of the heterotroph hypothesis that Oparin and Haldane said was those biomolecules, those polymers, had to self-replicate. So that's where life begins. I've been asked before, why are viruses not alive? Why is it biologists insist viruses are not living? We insist viruses aren't living because they can't replicate themselves. They don't replicate and they don't metabolize on their own. If you don't metabolize and you don't replicate, you're not alive. They're telling us those biomolecules that first formed would have had to self-replicate, and then you have life. How many of you are like, okay, this seems like a reasonable, like I might maybe be okay with this as a series, like a sequence of events? Seems rational, at least rational. Will you give Oparin and Haldane rational? No, but it's a bullet list. It's a 1, 2, 3. It's like postulates. It's saying, if this, then that.